Hey everybody, Brian here from quantlabs.net. Today I'm going to show you an overview of Simulink code generating into C++, or you could do it with C, doesn't matter. A very idiotic Simulink model, very basic, just to show you the complete walkthrough of how to set this thing up, how to visually build a training model, and then be able to code generate it into C and actually have it load up in your Visual Studio. Okay, I've shown this in a previous video, but I'm going to give you a general walkthrough of this whole process. So when you come into Simulink, just type in Simulink or you run it through somewhere up here. And then what will happen is Simulink will load up the block library browser, well, the blocks. And at the same time, what you got to do is you need to create a new model or open up a existing model. From there, that will bring up your canvas. Now, in a general nutshell, I've said this I don't know how many times, but this is your trading logic right here, your algo. But you could break it out with various model or blocks and have subsystems and things of supercharts within these other charts. But I've kept it really, as I said, really idiot-proof. Really basic. So basically this side would be your inflow, this would be your outflow. So here, in this case I have a TS, which is a time series. I don't know, some kind of parameter you may want to send as well. I've talked about how to generate this. This could be generated from a file, a mat file. Somewhere along the lines we've seen another example of it being fed in from a Excel spreadsheet, but I figured a way I might be able to do it via a database, so I've got a video on that. It's all speculative, but who knows. But right now this is just an array of these values, a constant, nothing fancy, and I'm just passing this dumb constant as well. So they're being fed into this chart. And then the other end, there's a result, which will show you how this breaks out, result, and I'll output it into a scope. From other examples I've seen, this can be anything that you create in Guide, it could be a chart, it could be pretty well anything. And in both of these, inflow and outflow, as I said in my previous video, there's ways, supposedly, you can build wrappers to Java jar files, so you can talk to the outside world via Java, as long as it's on the MATLAB's environment class path. So let's get into the chart. Now this chart is state flow. I've kept this real basic. So what we have here is we have a default transition, and then that will break into either two states, which is basically a buy or a sell. Now again, this is really idiotic, but it's just for demoing purposes. But you could go hogs wild on this and have large blocks and state flows and charts and galore. You can do all kinds of stuff. You can set up where there isn't a hierarchy, but this is, as I said, is just real basic stupid stuff. So what I've got here is I've created a what they call a MATLAB. Well, it's basically a custom function in MATLAB. Now, the funny thing is with this this piece right here. Here you have an action language called either the MATLAB M script, or you could use C. So this could be a C file, right? But for simplistic sakes, I'm keeping it as a MATLAB M function. This can be any M function as long as it can be generated via the MATLAB coder. Now there's a way I figured to generate these algorithms or future algorithms through MuPad and create through the MuPad language some very sophisticated algorithms and create functions from that. So that's pretty powerful stuff. And basically it's no different than any other MATLAB function. You do have to include this code gen directive to tell when it does run the process of code generating. I'll show you that in a little bit, that this is needed to tell MATLAB or the MATLAB coder that this particular function is being used for code generation. So obviously what we've got here, the names are kind of funny, I know. Just having this slap together took a couple hours to figure out what the problems were. But if you look here, we have these weird names, percentage PD, and then here we have PED. These all have to be unique names throughout the model. You cannot have anything unique. You may be able to, I have to still test it, but you can set these scopes of these values as a local or input output. So you may be able to get around that, but for now I'm just keeping everything unique because it just likes to bitch. Anyways, so what we do here is we've got the function, we have to predefine the returning the output value, so we have to predefine it as something, so that's what I've done, as 0. And then what we're just doing is just a quick summary of that time series I showed you, divided by the period, whatever the average number will be, and then bring back a result. So that's the function, and when you look at this, as I said, there's two states. So essentially, this transition, the very first thing it'll do when it comes into this stateflow chart, it will run or execute this MATLAB function as I've explained, passing into it the TS and PD, which is defined here, and that's also defined in the Model Explorer, but I'll get that in a minute. And when you do get the result of, I guess, the average, but in this case we're setting it here, what happens is we have to set two conditions. If the average is less than 50, set, I don't know, the by state, and if it's greater than 50, set it as a cell or whatever. I mean, it doesn't matter. But at the end of the day, there is a flag, I guess we could set, of a 1 or a -1 depending upon our by or cell. And then what you'll see here is on the input, on the TS or time series and the PD, and the result of that by or cell state in this particular case is the pause flag, and then that's fed into the scope. So how do we define all these values and variables and such? Well, there's this thing called the Model Explorer, and essentially what you have is it will create all of the objects through this Model Explorer, just a different view of it. But what you have to be careful of is you have to be really careful as you add in new objects, because as I said, you'll run into all kinds of weird problems. Like in this case, you might have conflicts of names and stuff like that. So you have to be really careful, especially if you're just starting out. I'd highly recommend you to watch the webinars and other postings that I put up on my blog to help me get to where I'm at today, showing this model within Simulink. So there is that you need to keep in mind. So we have all the different values, and you have all these different parameters and settings you can set. But in the chart, which is a state flow chart, we have all the objects, we have transitions. As you can see here, we have this transition average over a greater than 50, and then as you create those objects, they get displayed here, or it can be accessed through the Model Explorer. But here's the interesting part: to be able to create these input-output of TS, PD, and pause flag, I guess. What you can do is you can set the parameters here and say, okay, for that chart, This particular one's going to be an output, and then these two will be input. And then, as I said, there's a local one as well. But again, you also have to worry about your different types of variables and how they interact with your scope, depending upon your port, how you create that. Actually, I didn't create it, it was done automatically. And then you also have to make sure things like, in this case here, you can see that these parts here are this is Simulink. This is now part of stateflow. Okay, so that's part of the stateflow chart. When you see stateflow and chart, it's the same thing. All right, so where's my Explorer? So going back to this, you got to make sure you inherit the same as Simulink in order for that to work, because sometimes it'll default it inherits from chart and you get all those build errors. So also there's some other conflicts that can happen with inherited. You may need to set a constant size for the pause flag, as you can see here, in order to get around these errors when you simulate. You need to set them to be a constant. It's kind of not hard to figure out, but it is a kind of a mind bender when you're starting out. And again, the concept of Simulink, it's really based around electronics, like electronic boards and engineering. So you have to look at, when you're building these models, from that perspective, from an electrical background, really. That's why HFT shops like to work with guys and gals who has an electrical background because of this when they're building out FPGA boards. So that's the same concept here within Simulink. So we have two inputs that are created. Try to make sure you're always inheriting from the same as Simulink. This can be defined here. You can define all your different types. There's also a concept where you can create a bus object as well, but that's kind of more used for complicated, or I shouldn't say older models. But as it stands, this works as is. And I think that's it with the Model Explorer. It takes quite a bit of getting used to, but that's probably the hardest part. But once you get used to it, it makes sense. All right, so we've got a model, and then you run it basically by simulating or running it. So what I'm going to do is I'm going to bring up my scope. So here's the model. So this is the final output. Again, as I said, you can change the output to charts, guides, all kinds of stuff that Simulink has as a quote-unquote third party. But go on to the examples page, you'll find all kinds of great stuff. Okay, let's run it. So we just push this little, there is a debugger in it. I haven't really played with the debugger yet, but it's fairly sophisticated in MATLAB 2014B. So it's running right now, and you can see it, there's no errors at all. I think, there we go. But you can see, let me just run that again, but you can see there is an output of -1, which means we're always selling, I guess. Let me just run that again, but I want to show you some of the cool highlights. And see, you can see the data being sent within the chart, but also in the new Simulink, the MATLAB 2015A, you'll be able to see that simulation throughout the Simulink charts as well. So you'll be able to see data flow through the model. It's very cool. And there's also blocks that you can use to slow down the simulation, because it's very fast, as you can see. And then here, somehow you could probably put a live feed in to test it. Remember, this is all virtual. And that brings me to the next point. I've got this thing running, so now we're going to code generate. Okay, so essentially, I've shown this before in a past video. We have the C or C++ code. We can code generate. There is an advisor. I've shown that somewhat. It's pretty decent. But here's the configuration settings. There's a lot of settings. I've talked about comments. I'm just gonna do it all. Custom code. Now this is kind of cool, where you can add in header files and initialize a function. Now, I'm not sure if this is C or I think it's C. Terminate, and you can put your debugger info in there, I guess, depending upon your target. Which brings me to this. Now, I'm obviously in Windows. You can create many different targets depending upon your compiler. If you're using, I don't know, TI, Texas Instruments, or I mean, there's so many options here. You got this Verilog. You have various targets, but the one we're focusing on over the next little while is really this one. There is another one called GRT and ERT. You can use these in, swap them out. The thing is, sometimes this one may not work, or this one works as is. I guess it depends upon the model and how complicated your model gets for code generation. But as I said, this is a really simple, hopefully, I won't say idiot proof, but kind of works. Okay, so we got that set up. Now, oh, before I forget, yeah, there's a little trick here. There's two here. You'll see there's just a generic real-time target, but there's a specific one for creating a Visual C solution file. That's your Visual Studio, okay? So you want to make sure you pick off that one. All right, so we've got all that cool, fancy dancy set up. So you can just go ahead and build. Now you can generate code only. That's what I used to do, but I finally got this working, and it will load in my Visual Studio. This is 2013 Ultimate. So we're going to build. Hopefully this will be all okay. Here's an interactive. Yeah, we're going to apply whatever changes we just did. So there is a view. Hang on here. There's a view here for, there's a diagnostic viewer, so you can watch it build. So everything seems to be okay so far. It's completed. Now it's just building out the MSVC solution, which is the Microsoft Visual Studio. Now it's building it. So I never got this far with previous versions of MATLAB, and voila, we have our Visual Studio. Now remember, this is Visual Studio 2013. There's an error here, which is simple. Saying there's a block here, no problem. Basically, you'll get this error saying it's probably been set for Visual Studio 2010, but you can have one of two choices. Install this set of tools for Visual Studio 2010, or just basically upgrade the solution. So that's easy. We just upgrade the solution, go OK, and there you go. We've completed it. No failures, nothing skipped, and now we can go in and rebuild. So there you go. You have your complete source code, C++, your header for this visual model in Simulink. I find that's awesome because I've never gone this far. I don't have to futz around doing what I used to do by just generating code only. Where's that option? Yeah, with this option, that's what I used to do. Then build out my own DLL, but we now can do it right within Visual Studio. And we have the complete source code here. So you can imagine with this model, however you want to do it, you can generate now C++ code. And as I said as well in previous videos, you can create C++ or C, okay? And again, the HDL is very powerful for your FPGA boards. Like, it's just awesome. So you can do the same thing. I know nothing about FPGA. One day I will, but that is leading you into the path of, if you decided to go high frequency trading, just played a lot with the HDL examples that MathWorks provides for the HDL code generation, and that's specifically for FPGA boards. So you could build out very sophisticated models visually, and then be able to generate your code from it. Now, obviously, I know what you're doing, but the code's not too bad. But one of the things that I find that's really helpful, from my point of view, is to add in those comments. And you can see the comments are coming in. You can see it's from the chart that we talked about here, this guy, and then you can see maybe, you know, the entry, internal, chart, transition. So it's going to be one of these transitions. Here's the one for less than 70, or sorry, less than 50, which is probably this line right here. So here's the equivalent of the source code. But you can see the power of it, hopefully. But the whole idea is to trace it back from the source code back into the MATLAB, and this is the equivalent. And I do believe you may be able to get the MATLAB function as well. It gets code generated as well as part of this process. Let me just see here. So it's the name of test move average. So let me just do a search for that. And let's take a look at the equivalent in C++. There you go. So that's the equivalent right there, that little simple little function in C++, and that's converted from the MATLAB. So you can see the power of it. It's pretty straightforward. C++, nothing fancy, and it actually matches up with the actual variable names, which is kind of nice too. So from my point of view, this is awesome. I've pretty well tossed out everything else in terms of, you know, well, why would I work with C? Well, maybe C# for as a front end, or Java in my case, if that trick works for the embedded Java jar files with the wrapper. If that works, that's going to be awesome. The thing is, you know, you could interface it with our C++ through this with these means. I don't see why you do that. Not only that, this is cross-platform code, so you can put this on a Linux, Mac environment, and be ready to go. This is awesome, and as I said, you can build it as is with Visual Studio successfully too. So this is awesome, and good job for MathWorks for creating this sort of workflow. Next step is to be able to use something like, I'll just give you a little rundown here within the coder. There's something called MuPad, which is pretty awesome in itself. Come on, baby. Here we go. So what you could do is you could generate, it's its own separate language. You could generate your own code algorithms from scientific notation, and there is a methodology where you can take that code from MuPad and then convert it into MATLAB M functions, and then from there you can drop them into this type of function here. That's pretty impressive. Okay, so this is why you're doing 100% work through with MATLAB. And don't forget, with MATLAB, you have the power of the ability for backtesting and all that prototyping stuff within MATLAB. And now once you get it to a point, you can take it and be able to pretty well drop it within these kind of MATLAB functions in a state flow chart within a Simulink visual model, which is systematic. Okay, hopefully you see the power of it, and this is how I'm moving forward, because to be able to do this in such short order versus all the monkey ass that I've been working on, this is awesome, and I intend to bypass everything and just focus on this sort of stuff. Hopefully you see the value of it. Have a good day.